Hello, it's me again. I'm going to show you a brief 10-minute introduction, review, and some problems on the imaginary unit. Quite often it pops up when you start solving these more complex equations. We move away from linear equations will only give you real solutions or no solution or infinitely many solutions, but they're all real. It's when we move away from that real set of numbers and we start talking about quadratic equations, cubic, quartic, any equation with x to a power other than 1, you might start expecting some imaginary units pop up. So make sure you read the book, Google this topic. I'm going to give you, like I said, a 10-minute quick preview, introduction, you name it, for the imaginary unit, and have some fun doing it as well. So keep in mind, the imaginary unit is that unit that we square that equals -1. So in other words, if we take the square root of this, we get I equaling the square root of -1, which is pretty cool. Now here's where things really get interesting. If I take these bad boys right here, we're going to start having a little bit more fun with them. So I is equal to the square root of -1. I squared is equal to -1. If I were to square both sides of this, I would get I to the 4th equals 1, which is pretty awesome. And right here we got to fill in I cubed. That is actually equal to -I. So what happens here is, a lot of times we'll say, well, I is equal to, it's I to the first. I to the second, of course, is -1. I cubed, what happens here is I cubed is nothing more than I times I squared. When you multiply like bases, you add exponents. So we end up getting negative square root of -1, which is nothing more than -I. So this is a cute little chart, and what happens is we get I to the 5th equals I to the 1st times I to the 4th. Again, you multiply like bases, you add them, so 5 is equal to the I to the 4th times I to the 1st, so 1 plus 4 is 5. That becomes your, that becomes I again. Whoops. It becomes I again. And then I to the 6th, which is nothing more than these two right here. 4 plus 2 is 6. So 1 times -1 is -1. I to the 7th, we could go 3 and 4 again. That would be -I. I to the 8th would be I to the 4th times I to the 4th, which is 1. Then I to the 9th could be I to the 8th and this one, or whichever combination you wanted to do, 4 and 5. Regardless, that's going to be I again. I to the 10th, I could use I times I. If I wanted to, I could use I to the 5th times I to the 5th, which is I times I. Or I could just start looking at the pattern. It's I, -1, -I, 1, I, -1, I, 1, I, -1. It repeats every 4. So a lot of times people just go, I to the 1st equals I, the square root of -1. I squared equals -1. I cubed equals -I. I to the 4th equals 1. And then they know that it repeats after that. So when we get a crazy problem like what is I to the 107th, you can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. You can count all the way up to 107. Or you could say, well, if I'm 4 here, this is 8, this is 12, this is 16, this is 20. If it's 20 here, it's 40, it's 60, it's 80, it's 100, 101, 102, 103, 104, 105, 106, 107. That would be -I. That's one way to do it. Or you could say 107 divided by 4, what is the remainder? So 107 divided by 4 would be, what, 26 with a remainder of 3. 1, 2, 3. Blow. That's how we do it. That's how we do it. Now, quite often in mathematics, the only one you really need to focus on is this bad boy right here. That I squared equals -1. Pops up quite often. So here's what's going to happen. If I were to give you, say, a complex number, and a complex number would be a number that has maybe an imaginary unit like I and a real unit like 3, and if I wanted to add it to something as simple as 3i minus 4, well, we would treat these almost like we were adding binomials. So 1i plus 3i is 4i. 3 take away 4 is take away 1. well, I should have said 3 plus a negative 4, because, of course, we know that plus is an operator, and that is an operator. So, you know, whatever, as some of you say. If this had been I plus 3 minus 3I minus 4, what happens is, if you want to rewrite it as I plus 3 minus 3I plus 4, and that would give you I minus 3I is negative 2I, 3 plus 4 is 7, that would be groovy. But at the end of the day, what we're really going to focus on is what happens in these when we decide to simply multiply them together. So let's multiply these bad boys together. So what happens is we're going to use FOIL. So first is 3I times I is 3I squared. The outer is minus 4I. The inner is plus 9I. And the last is minus 12. And you'll quickly recall from FOIL that a lot of times the OI, the outer and inner terms, can combine together. So we get 3I squared. 9 take away 4 is 5. And there you have it. But remember what I said approximately 2 minutes ago. It's quite often that I squared. We're going to use that more often than not. So that I squared is negative 1 plus 5I minus 12. And what happens is this is negative 3 plus 5I minus 12. So this will be 5I minus 15. So a binomial, a complex number times a binomial complex number equals a binomial complex looking number. That's pretty cool. That's pretty cool. What's even cooler is much like a difference of squares where you have, you know, a minus b times a plus b is equal to a squared minus b squared, a binomial times a binomial equaling a binomial. Well, you can actually get a binomial times a binomial looking thing in complex number land equaling a monomial. And that's where that great word conjugate comes from. So instead of doing this, if I were to simply change this one to say 3I plus 4, let's look at the magic that happens in this scenario. So this is 3I times 3I is your 9I squared. We know what we're going to do with that I squared. The outer becomes minus 12I. The inner becomes plus 12I. And the last becomes minus 16. So of course the I squared is negative 1. These two cancel out. Minus 16. So now we are at negative 25. Negative 9 minus 16. Wow. That's pretty cool. That's pretty cool. Conjugates of each other. I'm going to just keep this video short and sweet because, you know, you can look, if you just Google complex numbers, imaginary numbers, introduction to I, you're going to get all this stuff. You've got your book, you've got other books. The last time I saw a student reading a math book, it was 1990 something. Holy cow. Yeah, but you should read your math book and read it like it's a romance novel. I know what some of you think. Yeah, romance novels, you skim through it and you get to the good part, you read it over and over and over again. You know, Bella looked at Eric and said, "Oh my, your skin sparkles in the sunlight." And he said, "What am I?" And she said, "You're a werewolf." And Eric slapped his head. I know his name's Edward, whatever. You know, you read that part in the Twilight book like 15 times. Yeah, you know who I'm talking about. So let's do one more problem. One more problem. What will happen is somebody will give us 3 minus 4I over 5 plus 2I, and they'll want us to write this in this a plus bi form. Well, don't let it scare you. They just want you to write it as a complex number. So what will happen is, remember, it's a fraction. We can't change the value of it in math. All we can do is add 0 to it, or we can multiply it by the number 1. So I'm going to multiply this by the number 1, which will be in the form of the denominator's conjugate. Now let's use a little bit of FOIL here. You've got to use a lot of FOIL here. Holy schmoly. So 3 times 5 is 15. The outer is minus 6I. The inner is minus 20I. And the last is positive 8I squared. The bottoms are your conjugates. So 5 times 5 is 25. The outer and inner cancel out. And the last is minus 4i squared. So what we end up getting now is, keep in mind, I squared is negative 1. So a negative 4 times negative 1 is a positive 4. So that will give us a denominator of 29. Again, this I squared right here is negative 1. So negative 8 and 15. 15 take away 8 is 7. And then we have minus 26i. And the way the textbook and the way that if you are sitting at ECU in the cave, you know, and using my math lab, they would want you to write this as 7 over 29 minus 26 over 29i. That is how you take something like this and rewrite it in the form a plus bi, where b is the coefficient of the imaginary unit. So I hope this video is really helpful. I know that's really quick, down and dirty. And stay tuned for some more videos on the quadratic equation and then solving other equations that aren't quite quadratic, but a little bit higher in degree. See you later. Yes, I'm running around to cut off the video.